Just as a reminder, while we perform the number of rounds here, so according to the number of rounds, we have round 1 up to round 16. So this is round number 1, round number 2, round number 9, and round number 16. For that, they have to shift the number of bits to the left by 1 bit here. Okay, it's just for remembering 1, 2, 9, and 16. 1, 2, 9, and 16. The number of bits to be shifted to the left in case of key generation is 1 bit, whereas for the remaining number of rounds it is by 2 bits here. Just to understand, you just remember for which round the number of bits is shifted by 1 here. The 1, 2, round number 1, 2, and 9 and 16 here. You remember this one, and the remaining you can fill with 2. So this is the compression box, what I told you as a permuted choice 2 here. So if you look at this one, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6 here, 6, 8, 48. So only the 48, this is the position of the bits here. Okay, this is the positions of the bits here. Only these positions of the bits we have to use here. What is the bit in position 1, either 0 or 1? What is the bit in that position 5, either 0 or 1? You have to fill and use this table here. Okay, and the remaining bits we have to ignore it. This is what we call it the permuted choice 2. Okay, or even we call it the compression box. But if you look at again what is an expansion box here, so we have in expansion box, if you understand this one, from there we have this 32 bits here. Then after performing the expansion table, it becomes 48 bits, right? 48 bits here. So how actual expansion table is work? So we write all the 32 bits here. Okay, 32 bits here, having a group of 4 bits here. Okay, from 1 to 32 we have written here, and then we just arrange in this manner, and then whatever the bit that comes after the last one, we write after this column, and whatever the bit that comes previous to this one, we write before this column here. Okay, so what is the bit that comes after 4? It is 5. What is the bit that comes after 8? It is 9. What is the bit after 12? It is 13. After 16 is 17. After 20 it is 21. After 24 is 25. After 28 is 29. After 32 we don't have this 33 here. Okay, we have only 32 bits. So there is a circular shift right now. So it will be 32. After 32 we have this 1 here. So what is the bit before 1? We don't have 0 bit, so it is 32 bits here. What is the bit before 5? It is 4. What is the bit before 9? It is 8. Similarly, before 13 it is 12, and so on. Okay, so if you count the number of total bits here, the whole box, if you count it, there are 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. So 6, 8, 48 bits here. So after expansion, we got this 48 bits here. These bits and these bits are added extra, and then we make it an expansion table. From the 32 bits, we make it up to the 48 bits here. Okay. So if you look again the S box, if you look again this S box table, so from the right hand side we have that 32 bits here. That particular 32 bits, that is one here. From the right hand side we have this 32 bits right now. That from the 32 bits, using the expansion table, I expanded up to 48 bits here. Okay, 48 bits here. So that particular expansion table, from that right hand side I expanded, I got it this 48 bits. How actually we expand it? We use the previous table of expansion, and then this is the key from the key generator. Okay, this is the sub keys from the generator here, like this one. This is the sub keys from the generator. So this one and this one, after expansion, they have to perform the XOR operations here, and then they have to go to the S box here. Okay, so the after expansion we have 48 bits. After expansion after key shifting, we have this 48 bits here. Okay, 48 bits here. You know how actually we come across this 48 bits from the given key as a sub key. Perform the XOR operations, obviously we have this 48 bits here. Okay, so we have to arrange these 48 bits into this 8 S boxes here. We have 8 boxes. Okay, 8 S boxes here. So this particular bits, we just form the group of 1, 2, 3, 4, 5, 6. In a group we have 6 bits here. Here also 6 bits, here 6 bits, 6 bits, and so on up to 6 bits. So 6 8s are again 48. So 48 bits are arranged in 8 groups, and each group having 6 bits here. These are nothing but bits here. Okay, nothing but bits here. So after if you look at this particular diagram, after going through these S boxes, these 6 bits, we have only left with the 4 bits here. Means 2 bits are removed. Okay, so how actually we remove this one? We'll go to the another table. So how actually we perform the operation? Once we got the result of the XOR operation, we distribute them into the 8 S boxes. Each 8 boxes are input with the 6 bits here. Once they input to the S boxes, the output will be having only 4 bits here. Then if the total number of output from the S boxes are 4 into 8, 32 bits here. This 32 bits we have already generated this one. Then again they perform some permutations, and then this 32 bits come as the output here. They perform 48 bits, perform the operations, and then we come the 32 bits. The next 32 bit we perform the permutation choice, and then we get this 32 bits here. Okay, so this is how we got this 32 bits here. But let us see how actually this S1 works here. Okay, how actually this S boxes, how actually this from out of the 6 bits, how only 4 bits are generated here. So if you look at this one, so this particular values here, these particular values are different for each and every S boxes here. This particular patterns are different for S1, are different from S2, are different from S3 up to S8 here. So they are already predefined. So suppose I have the bit as 1 0 0 0 1 0. Okay, if I have this kind of 6 inputs, 1 2 3 4 5 6 inside an S box here, okay, then I have to output will be only 4 bits here. Output will be only 4 bits here. So how to generate this one? So you consider the outermost bits here. Okay, these 2 outermost bits, you consider it. So you just keep the priority from from left hand side to the right hand side here. So 1 and 0, and then the remaining one. What is the remaining bits? 0 0 0 1 here. 0 0 0 1, and the outermost bits are 1 and 0 for this particular examples. Then you look up this particular S box table here. Okay, since I am showing here for S5, okay, it is also different from S1, but the technique is you consider the outermost bits and you just consider the remaining bits, inner 4 bits here. Okay, this particular outermost bits, outer bits will form this one here, and the outermost part will form the arrangement here. Okay, right now the outermost bits this side and the innermost bits this side here. So you just find the matching point. What is the outermost bit? It is 1 and 0. This is 1 0 here, obviously. What is 0 0 1? This is 0 0 1. So the particular value is this one. So it will be 0 1 0 0. Looking up to this one, 0 1 0 0. So you, like this one, you have to find the number of the outermost bit and the inner 4 bits, and then you have to find a matching point according to which S box you are using here. And this particular table we need not by heart it. It is predefined. It is already given in the DES algorithms here. Okay, so So like this, we have from that we have generated these 4 bits for S1, S2, S3, S4, S5 and so on up to S8 here. Now we have this 32 bits. You go for permutations and then there will be the output as 32 bits here. Then this 32 bits you need to perform the XOR operations again with the left hand side, and then you fill the right hand side here. Okay.